Hello everyone, so I'm here today for a short lesson on average value integrals. So let's go back to, like second grade or something and talk about something else. What if I want to find the average of three numbers? Let's say 3, 6, and negative 2. Well, how do we do that? Well, all of you guys know what I would do is I would add them together and then I divide by the amount of numbers. So in this case, I have 3 plus 6 plus negative 2, and I had three numbers, so I divide that, and I would get an average of 7/3. Okay, but hey, we're not here to take the average of three numbers, right? This is calculus. So what if you want to do an average of an infinite number of numbers? And particularly, what if you want to find the average value of a function, f of x, on some interval a to b? So all the different values of f of x from 0 to 5 or 2 to 4 or something like that. Well, that average value is equal to 1 over b minus a times integral a to b of the function f of x. Okay, and you could also, if you wanted, just put the b minus a in the denominator, do a to b of f of x dx over b minus a and write it out like that. Like that's a totally fair way to do so. Okay, but again, take a look at that. So what's going on here? Again, it's like what we're doing before. So we're taking a sum, an integral is like a sum. We're taking a sum of the values and we're dividing not by the amount of numbers, but by the width of the interval. So if you're going from 3 to 5, you have a width of 2, you divide by 2. Okay, so that's our key formula, and this is really the only new thing in this video. We'll just talk about some applications of that. So let's talk about some examples here. But this average value, this idea of like find the integral to sum them all together and divide by the width, that's the key. And look for this anytime you see an average value, average height, something like this. So suppose I tell you to find the average value of f of x equals 1 plus x squared on the interval from -1 to 2. Okay. Now, when you see a problem like this, you see the word average, which is an indicator we're going to do this. And this -1 to 2, that's your a and that's your b in this formula. So that means that this average is going to be 1 over 2 minus 1 times the integral -1 to 2 of your function, so of 1 plus x squared. Now, from here, like you guys know how to do this integral. There's nothing really new or different here. This is just 1/3 times, okay. I like to leave that 1/3 in front and kind of deal with that at the very end. So this integral is x plus x cubed over 3 going from -1 to 2. So I'm going to leave that 1/3 in front and then kind of put some big brackets. So when I plug in 2, I have 2 plus 8/3. When I plug in a -1, I'm subtracting. Okay, so that's -1, and then -1 cubed is -1 over 3, like that. Excuse me. Okay. So let's simplify everything that's going on in here. So this is 1/3 times, and that's 2 plus 8/3, and then minus becomes +1 plus 1/3. So that's 1/3 times 2 plus 1 plus 9/3 is 6, which is 2. Okay, so excuse me. What that tells you is the average value of the function from -1 to 2, it has a value of 2. I also want to talk about this graphically, because this what this represents is if you were to look at what a graph of this function is, if you have a function y equals 1 plus x squared, we're saying if you looked at what happened from -1 up until 2, it just gave the average height of all the points in between. So like here we have, a height at this endpoint, a height at this endpoint, and it just finds the average height of everywhere in the middle. Okay, so that's like a geometric interpretation of what we're finding. And again, it's the same idea, just sum all of them together and then divide by the width of the interval. Okay, so let's give you one now. Let's try to find the average height of, let's say, f of theta. Let's not even give you a function. Find the average height of 4 sine theta on the interval from 0 to pi over 3. Now, if you want to pause this and try this on your own, not a bad idea. Okay, so let's go ahead. This is your f right here. This is your a, and that's your b. So this will be 1 over pi over 3 minus 0. We're going to talk about dealing with that constant in a minute. Times integral 0 to pi over 3 of 4 sine theta. And I want to talk about kind of dealing with this constant here. So this is 1 over pi over 3. How do we integrate 4 sine theta? Well, let's see, the integral of sine is negative cosine, because the derivative of cosine is negative sine, so we flip that. So this is negative 4 times cosine of theta, going from 0 to pi over 3. And one thing you can kind of do is you can combine those constants, and this is something that might save you some time. So this is like 1 over a fraction flips it, so that's 3 over pi times negative 4 cosine theta, going 0 to pi over 3. So you can combine that into negative 12 over pi times the cosine of theta, going from 0 to pi over 3. Okay, so that just becomes negative 12 over pi is in front. And then we do the cosine of pi over 3 minus the cosine of 0. Now, you're a good calculus student, of course, so you know that the cosine of pi over 3, let's see, that's the first angle over, so that's 1/2. You know the cosine of 0 is 1. So we get negative 12 over pi times negative 1/2. Oh, that did not look good. Times negative 1/2. So that just ends up being 6 over pi, like that. Okay. So again, that's the average height of the function, the average value. You're integrating, you have your A to your B. Let's look at an example with the Riemann sum. So I took some data. You haven't been there, but the fridge in my classroom is terrible. So let's say the temperature in my fridge is recorded in this table. So we have a T, we have some F of T. And I measured this at various days. So day 2, day 4, day 7, and day 10. And I got temperatures in Celsius of 3, 5, negative 1, and negative 3. Sometimes it freezes my lunch. And what we're going to do is we're going to estimate the average temperature from T equals 2 to T equals 10 using a left Riemann sum. Okay, so let's see. First off, the 2 and the 10, that's the A and the B in my formula. So what this is going to turn out to be is we'll have 1 over 10 minus 2 times integral 2 to 10 of this function f of t. So we have a 1/8 in front, but what we're going to do is we're going to leave that 1/8 in front, and we're going to estimate this integral using a Riemann sum. So this integral, we don't have an equation for f, so we're going to estimate the integral using a left sum. Okay, so let's write these out. My intervals here, I have 2 to 4, 4 to 7, and 7 to 10. So I'm using the height at the left endpoints. We have a base here of 2, a base of 3, and a base of 3. Okay, so let's go ahead and work this out. So the first interval, we have 2 times f of 2 plus, here we have a base of 3 times the height at the left endpoint there. Here we have base 3, height at the left endpoint there. Okay, so this becomes 1/8 times, let's get the values from the table. So that's 2 times f of 2, so 2 times 3, plus 3 times 5, plus 3 times negative 1. Now again, this is an estimate because it's a Riemann sum, but let's figure this out. So this is, that should be a 1/8. So this is 1/8 of 6 plus 15 minus 3. So that's 1/8 of 18. Also known as 18/8. I guess you could simplify it like 9/4 if you want. So let's take a look at that. That's like 2.25. So that's our average value. If we look at the data in the table, does that make sense? Like, does an average value of 2 point something seem reasonable? Yeah. Like, if you'd done this problem and looked at those temperatures, I got an average value of 30 or an average value of negative 10. Immediately you would know that that was off. So just by doing this average value, that gives you an indication that you're headed in the right place and your answer is probably correct. Okay, so that's how you do it with a Riemann sum. Only one more thing I wanted to show you today. This is a fun fact. This isn't something like you'll need to know necessarily, but I want to show you where a formula comes from. If you remember back from like our first or second chapter, we talked about an average rate of change. And the average rate of change formula, remember, is f of b minus f of a over b minus a. And you might wonder, does this relate to this average value? So a rate of change is talking about a slope. So we found a slope between 2 points. But let's say we did this. Let's say we found the average value of the rate of change. And I'll show you where that formula comes from. The average value of the rate of change. Well, the rate of change, of course, is just f prime. So if you find the average value of f prime, that's 1 over b minus a times integral a to b of that f prime. Now, thinking about what that's going to look like, that's 1 over b minus a times, how do you integrate f prime? Well, you get f of x. and that's going from A to B. So you can see right there, this is just going to be 1 over B minus A times f of B minus f of A. Oh my goodness, that's this equation. It worked. Okay. So that's where you got this average rate of change formula, by just doing the average value of f prime. Okay, so this is pretty cool. All right, bring me questions, class. Hope this helped, and I'll see you guys soon.